Hello everyone and welcome back to another video. And today I want to show off a very cool function of the Elma EVC that I think I've showed off before, but I've never given it a very good tutorial, so now I'm going to do that. And that function is the use of the onboard DAC of the EVC2SX. The older EVC variants also have this and the newer ones will also have it. There are some slight differences, mostly in the amount of currents, like the current steps that the DAC has, but the functionality will be the same. So the Elma Labs EVC2SX is a little device that you can buy from Elma Labs. It costs about $35 if I remember correctly, and this is a very, very powerful little extra board that you can use for all kinds of overclocking things. The main use case of the EVC2SX are these three I2C bus connectors, which enable you to talk to digital voltage controllers directly and just directly change registers on them. Basically, you have complete control over the controllers that way. But not every PWM controller does support I2C. For example, the controller on this GTX 560 Ti, that would be right here, that is a UP1608P. That one doesn't support I2C, so we can't talk to that controller over these I2C buses because this is not a digital controller. This is a dumb controller, so to say. But we can still use the EVC to get our Voltmodding out of this controller. Now we won't get any fancy things such as changing the switching frequency or the load line calibration. That one only works with digital controllers. But we can still get a Voltmod going, and that Voltmod will actually be simpler than doing a traditional Voltmod using a potentiometer. Now traditional Voltmods, feedback pin mods I should say, work the way that you measure the resistance of the feedback pin of the controller, you multiply that by 20, you get a fitting potentiometer, and then wire that potentiometer from feedback to ground, and the lower you set the resistance on that potentiometer, the higher the output voltage will be, because the controller assumes that the voltage divider at its feedback pin always stays the same, but when you solder on that potentiometer, you change the ratio of that voltage divider, and therefore the controller starts receiving voltage readings that it tries to compensate for. Now the EVC2SX can do something very similar. The difference being is that you will solder your mod between the feedback pin and the output, not ground. And we will be using the EVC for this. Now, yeah, you need this. It's probably more expensive than a little potentiometer, but using this enables us to first get voltage monitoring, and second of all get very nice, precise control, in most cases that is, over the output voltage. And of course we only need two wires and don't have to glue a potentiometer to the card in any way. And you know, of course this is also reusable, so you don't need to buy an EVC for every card you mod. So the way all this works is using these outputs here. Now the very first is a ground pin. You don't have to, but probably should connect this one. That's just to make the voltage readings that the EVC gets better. You can just take an alligator clip, connect the ground pin to something like the I/O shield of the card just to make sure that the EVC and the card both have the same ground potential. And then you will see that we have pins called SRC1, V1, SRC2, V2, SRC3, and V3. Now these are the points where we can have three of our DAC powered Voltmods. SRC is the pin that we will connect to the feedback pin of our controller, and V is the pin that we will connect to the output of our VRM. So V1 is used to measure the output voltage, and SRC is the output of the DAC. Now instead of changing the ratio of the voltage divider at the feedback pin, the DAC can ingest or take away small amounts of current from that pin, which effectively does the same thing as skewing the voltage divider with a potentiometer, only that it can all be done within the EVC software. And we will also get a very nice voltage measurement graph from our voltage pin. That's basically what it does. And yeah, that's basically what it does. So the function is very similar to our normal feedback mod. It is a little bit more elegant because you don't need to measure any resistances, you don't need to get a fitting potentiometer, you only need to solder this on. And then of course you get the software readouts of that from that voltage sense pin. One disclaimer is that the resistance of the feedback pin does directly affect how big the steps are, because the steps on the EVC are in microamps. But if you have a controller that has a very low resistance on the feedback pin, setting plus or minus 10 microamps is not gonna do much. If you have controllers with very, very low feedback pin resistances, for example the CLJ8266 or the CLJ8318, they have basically no resistance on the feedback pin, because on those controllers the feedback pin is basically directly connected to the core. On those controllers this mod will not really work because the resistance is so low that taking some current away or adding to it is not going to do anything. In the same way, if you have a controller that has a very high resistance on the feedback pin, your small current steps are going to translate to some very big voltage steps. For example, when I was modding the HD4550 for the Cheap Ass Chips Round 2 competition, I had a controller where one step, like the smallest step, which I think is 10 microamps on the EVC, translated to already 100 millivolts extra voltage on the card. Now you can also end up with a card like that. Most cards should be in between that, so in most cases it should be fine. But just be aware that you could have a card where it doesn't really work. Now, the cards with the very low resistances, all of those I've encountered did actually also support I2C, so you could just use the I2C bus of the EVC to talk to that controller. So it's not really a big issue. The ones where the voltage steps were really, really high, those were usually some 8-pin single-phase VRM controllers that you typically see used for memory VRMs, but on some super low power cards they are also used for the vCore VRM. I think we actually have one of those controllers. Yeah, it's right here for the memory VRM on this card. So you see the 30 MOSFETs on top, and then under that there's this one little 8-pin IC. That's one of those that I mean. Doesn't mean that this controller will have those big voltage steps. It depends. This package is used by a lot of different single-phase voltage controllers. So, yeah. And on the memory VRM, 100 millivolts per step is not even that bad, actually. But yeah, just be aware of that the DAC steps are in microamps, and it does not correlate with the voltage. I mean, it does correlate with the voltage steps, but you can't compare it between cards, because different voltage controllers and the different ways in which the feedback pin can be set up will translate to different voltage steps. So if one card does 1.2 volts at minus 50 or plus 50 microamps, it doesn't mean that the other card will do it too if it has a different controller. But yeah, let's get into actually modding this card. So I've loaded up the datasheet on my computer, and I'm just gonna show it here. So we will be looking at the pinout of the UP1608P. There's also a UP1608Q, that's only a 2-phase controller, but this is the 4-phase variant, seeing that we have 4 phases. And we will be looking for the feedback pin. Now on most controllers it's named FB. Sometimes it's named something different. Some controllers name it Sense Plus. Again, those controllers that have a very low resistance, because some controllers elect to not have a voltage divider and just directly grab vCore voltage. On those it's sometimes called Sense Plus. But on most controllers it will be called FB or feedback, and in this case it's called FB. Now we will need to find the FB pin. There will be a diagram in the datasheet, and this controller will have an indicator on itself and on the board where the top left corner is. Now you can see that on the board we have this arrow pointing to it, and on the controller itself we also have this little white dot that shows that it's the upper left corner, because that's how it's orientated in the datasheet. And then, if I remember correctly from looking at the datasheet, The feedback pin should be somewhere down here. Now I will double check where the feedback pin is, and I will identify a IC component on the board right here, because we can't solder directly to the pin. I'm gonna have to find something here on the board, like a capacitor or a resistor, that we can then solder to. So that's where our SRC wire will go. And then we will just need to grab a positive end of the VRM from any point where there is V-core voltage. So we could use the output leg of the inductor, we could use the positive end of a capacitor, or if we can find a bit of exposed power plate or like an empty capacitor pad, we could also use that. We could also scratch off the solder mask and use that. Just anywhere where there's V-core output voltage, that's where our V pin will go. And that's how the mod works. So I'm gonna be checking where the feedback pin is, and I will be soldering on some wires that we can then plug into here. And then we will have our voltage control on a controller that doesn't even support I2C. So I've attached the wires now. I had some difficulties with the one for the controller, so I decided to put it slightly somewhere else. There's more components than just the one that I marked that are actually connected to the feedback pin, because there's a voltage divider. There's just not one resistor. There's actually, I think, 3 resistors and that one capacitor that I ended up choosing. And then for the positive end, I just chose a V-core capacitor behind the core, so we get a bit more of an accurate voltage measurement, because your voltage drops a bit from the VRM output to actually behind the core. And yeah, so now we have these 2 wires. So we take our EVC, and this goes into the V1 pin. This goes into the SRC1 pin. And then we would have another like ground connection. Let's take that. And just take an alligator clip like that and connect that to something like our I/O shield. Now it would be completely set up. We connect the USB-C for the EVC, connect it to our main PC, and then we can control this over the software, and that's what I'm gonna do now. So now the card is set up, and you can see everything's running, and you also get your preview here for how everything's set up, pretty much the exact way it was. The alligator clip is into the I/O shield so that we have a common ground between the EVC and the card, and our voltage sense and our SOC pin are still connected to the card. Now in the lower right corner you can see the EVC software, where I've already selected the DAC menu, this one. Usually you would end up on this page, and then you have all your I2C connections, your SPI BIOS flash connection, and then you have your DAC over here where you get this nice voltage graph. If you ever wondered how I get my voltage graphs in my recording videos, that's how. So, card is running Unigine Tropics, and we have MSI Afterburner open, and I want to demonstrate something. You will still be able to do this. See how voltage went up? So this does not deactivate the software voltage control on the card itself. If you use I2C to talk to the controllers, that usually disables software voltage control, because the I2C bus, that like the EVC, basically gives itself a higher priority than any MSI Afterburner or whatever other program you use. So it will ignore whatever you do there. If you do this, well, it's not digital, it's completely analog. So your software voltage control will still work, just like normal, except that now you can set an offset. So we could, let's say, take some voltage away again, or we could add some voltage. So we're at 1.13-ish, and now at 1.15. So I could, if I wanted to, take the offset away again that I just set in software, or I could add more to it. Alright, 1.16, that's higher than we can select in software. And you can see that the temperature changes. So that's your proof that it actually applies, if this isn't proof enough. So yeah, that's just how simple it is. You can set your offset here. It doesn't override anything in software. Just keep in mind that when you set something in software, the offset stays. So whatever you select in software, like if you select 1.15 in software, well, you might not actually get 1.15, depending on what you have entered in this drop-down menu. And I'm kind of sad that you can't see the drop-down menu itself. You can only see what I select. But the drop-down menu goes from this all the way to this. And yeah, that should be enough range for all the cards you need. So let's see if this thing does 1.2 volts or if the VRM is gonna give out. There's 1.2 volts. Yeah, so that's how you can Voltmod cards that do not support I2C without using any potentiometers or having to calculate what size to use. And you get this nice voltage graph, you get very consistent voltage control, because turning a potentiometer is, I mean, you can compare with the multimeter, you can just compare output voltages, but if you want one exact setting, turning a potentiometer is kind of difficult because it doesn't, like, it's a continuous knob that you turn. Here you get some very distinct steps. So that's, I mean, not very useful, but it's a bit nicer than having a potentiometer. And yeah, and also as you can see, because we have 3 of these, we could have also modded the memory VRM or the PEX VRM, or if this was an AMD card, the VDDCI VRM. So up to 3 at the same time. Or, I mean, you could also get multiple EVCs, then you can have 6 or 9 at the same time for SLI cards. And yeah. And one last thing that I would highlight is down here in the EVC software, you actually get a little explainer of how this works. So there's 2 versions. What we did is the feedback mod. There's also the reference version, which newer NVIDIA cards use 10 series and up, where you don't really have an FB pin. Well, those controllers still have an FB pin, but by going to the VRF and REF-in voltages, you can override anything that the NVIDIA driver does to you. Though actually for that you would have to desolder some resistors. But you can also use the VREF and REF-in pins on some newer controllers instead of just the feedback pin and the output to do this kind of mod. I've never done this kind of mod on a card before, so I can't specifically give you instructions on how to do it. But for this one, well, this is this video on how to do it. And you also get this little pre-calculation thing where like it is showing the voltage divider here that the feedback pin has. So basically it wants you to measure the resistance from the feedback pin to the output and then the resistance from the feedback pin to ground. Put that resistance in here, measure the voltage you get at the feedback pin, and then it gives you it gives you a rough estimate of like how changing the offset would, what kind of output voltage that would give you. I've never really used this. When I get a new card, I just usually set 10 millivolts, 10 microamps first, because that reduces the voltage, and then I see by how much it reduces it, and then I know by how much I can increase it without accidentally like breaking the card. That's how I do it. I don't really use this functionality here, but you can if you want. So that will be it for the demo of the EVC2SX DAC. Pretty cool feature if you ask me. I actually for a long time didn't even know that this existed, and when I learned it existed, I fell in love with it right away because it just makes modding cards so easy. The main thing why I love it is you get this nice graph, and you don't have to bother with a multimeter at all. And of course you also get this very nice control over what voltage you get. All without ever having to figure out what kind of potentiometer to use again. So I really like this function. If you have an EVC, you should probably try this. It might still be more convenient to just potentiometer mod some cards because, well, you do need to set up your EVC every time you want to use this. But I think this is a really cool feature. That is definitely worth checking out because it expands the use case of the EVC by so much. Not just I2C capable controllers, but just basically every controller, except for those few where like they don't do I2C and the steps are way too big. Those you're still gonna have to mod with a potentiometer. But I've only ever run into one controller that does this. All the other controllers I've tried with the I2C, with the EVC, either supported I2C or worked pretty well with this DAC function, like this controller right here. Like one step should be around 10 millivolts. Like we get 1.135-ish here, and if we set 10 millivolts, yeah, like it floats around 1.1545. So it's around 10 millivolts that you get per step. So that is an okay control granularity, if you ask me. And yeah, so that will be it for the demo. So thank you all for watching. Hope you enjoyed, and until next time, goodbye.